Yep.
Hold on 1 second. Okay, go ahead.
Okay, so it says consider the polynomial function q of x is equal to 3x to the 7th plus 5x to the 5th minus 8x to the 4th.
Hold on, slow down a second. 3x to the 7th minus 5x to the 5th
plus 5x to the 5th. And then minus 8x to the 4th minus 12x squared.
Okay. What is your task?
It is saying what is the end behavior of the graph of Q.
Okay. When you are talking about end behavior of polynomials, the only term that matters is that one right there.
Okay.
All the others don't have anything to do with it. And in other words, we have a function here that's the only thing I need to know what it does.
Okay.
And that is an odd number, 7.
Mm-hmm.
And that is what's going to determine the end behavior. So if I'm looking at left-hand end behavior, which is to say x goes to negative infinity, what is this going to do?
It will be x goes to positive infinity.
No, if you substitute negative infinity for x and you take negative infinity to the 7th power, what do you get?
Downward.
Correct. You get negative infinity. In other words, if I had x squared as my lead term and x goes to negative infinity, then it would be positive infinity. And in fact, that's what a parabola would look like. Notice that as I'm going this way, I'm going to positive infinity. But if I had a cubic, like this, now as I'm going to negative infinity, I'm going to negative infinity. And as I'm going to positive infinity, as x goes to positive infinity, f of x would go to infinity.
Okay.
So that's really all you need to do is substitute negative infinity or positive infinity, pretend that it's a variable or a number, even though we know it's not. The fact is if you take negative infinity and you cube it, you still get negative infinity, but if you square it, you get positive infinity. So that's basically the way it works.
Okay.
Okay. Do we still need that function, or can I erase it?
You can erase it.
Okay. Or they don't have any other questions on that?
No. So here's the. Oh wait, actually, no, it's not the same thing. Here's the next question.
Okay.
So, f of x is equal to x parentheses x plus 3 parentheses x plus 1.
And further parentheses like that?
Yeah.
Okay.
And then one more parentheses x minus 0 has zeros at x equals negative 3.
Hold on. Oh, has zeros at, okay. So,
and the minus 0 is a 4.
I was going to say, usually they don't write the minus 0. I figured they were trying to just trick you up. Minus 4?
Yep.
Okay.
And then has 0.
That's our polynomial in factored form. In other words, we're looking at 4 linear factors. What's the question?
So then it says has zeros at x equals -3.
Okay,
X
comes from
equals
that one right
1.
there. Comes from that one. You see why?
And x equals what?
Do you see why? How I get the -3
Oh, yeah.
from the x plus 3? In other words, I'm setting each of these factors equal to 0.
Okay.
Okay?
And so then x equals -1, x equals 0, and x equals 4.
Those are your 4 zeros.
Okay.
Once you
And
get
then,
it in factored form, it's pretty easy to find the zeros.
okay. And then it's asking what is the sign of f on the interval of -1 is less than x, and x is less than 4.
Like that?
Yeah.
Exactly.
Yep.
And what is the sign on that interval?
Yeah. Sign of f.
Well, it changes signs.
And so then it has like the options of f is always positive on the interval,
Okay.
f is always negative on the interval, and f is sometimes positive and sometimes negative on the interval.
Okay. So, pretty sure that it's that last one, because what
Okay.
we have here is a quartic. This is a polynomial that is x to the 4th is going to be its lead term. Okay?
Okay.
Quartics tend to look something like that. No, excuse me. They're going to look more like, well, here, let's talk about this for a moment. What do we know
Okay.
about this function? We know it's zeros. Okay, I'm going to put them with an x. There's the 4 zeros, correct?
Yeah.
If you want, I'll label them. That's -3, -1, 0, and 4. And we know the end behavior because the lead term would be x to the 4th, right?
Mm-hmm.
What's the left-hand end behavior?
The left-hand end behavior is negative. Or no, positive.
Exactly. So we know we're coming from this direction. We're not coming from down below.
Mm-hmm.
Okay? We also know that it crosses and does something like that. That's what quartics look like. With 3 extrema. Have they taught you about extrema yet?
Extreme end, I don't think so, no.
Absolute minimums, relative maximums.
Absolute, let's see. They talked about maximum and minimum, like stuff like that, but
Okay. Let me introduce you to it then. Let me change colors. If you look at this area right there, that is a relative minimum. Why is it a relative minimum? Because I can find points on the left and the right that are both higher than that lowest point in the blue.
okay.
That makes it a relative minimum. This is a relative maximum for the same reason. I can find points on either side that are less. That's all it takes to be a relative minimum or a relative maximum.
Okay.
You have another relative minimum there. And the general rule of thumb is that you're going to have one less of these relative minimums or maximums then the degree of the polynomial. We're dealing with x to the fourth, so we would expect 3. And that's what we have. Notice that when you have x squared, you have 1 relative minimum.
Okay.
Okay. When you have x cubed, it usually looks, a typical x cubed function looks like this. You have 1 relative maximum and 1 relative minimum. In other words, you have 2. Now, not all x cubes look like that. In fact, if I were to graph x cubed all by itself, you don't have any relative minimums or maximums. So you don't have to have 3 for our x to the fourth situation, but you can't have many more than 3. Just like x cubed can be like that, where it has none.
Okay.
But most x cubed functions are going to look like that, where they have 2. 1 relative minimum, 1 relative maximum. So your possible answers were, it's always positive, it's always negative, sometimes it's positive, sometimes it's negative. From this graph, it's sometimes positive, sometimes negative. Now, it might be worth substituting a number in there just to prove it. I'm thinking for a second. Let's see. Yeah, it appears that right below or right to the left of 0, it would be positive. So let's try minus 1/2 in there. Okay. That would give us positive 3.5. Oops, excuse me, 2.5. Positive 1/2 and minus 4.5. Notice that if we multiply all 3 of those or all 4 of those together, we get a positive number. So it's definitely positive right to the left of 0. There's something I'm trying to remember and I can't. It has to do with whether it crosses the 0 or kisses it and comes back up. Oh, I know why. Yeah. All of these, I couldn't remember. All of these zeros are, there's only 1 0 there. It's not an x squared. Okay? By that, I mean, go back and change this and make that x squared. Okay? Now, I still have a 0 for that. But at that 0, because it has a multiplicity that is even. Have you talked about multiplicity yet?
I don't think so.
Well, I might be going too far with you. It'd be better to let you get some of this in class. Although maybe not. You might be better off understanding what's coming if you know a little bit about it. You're in a PreCalc class?
No, algebra 2.
We've been through this before, haven't we? This conversation. What are you doing these kind of hard, difficult problems with algebra 2? You may not get to multiplicity yet.
Okay.
But multiplicity has to do with how many zeros there are. In other words, this problem actually has 5 zeros the way I've written it, with x squared.
Okay.
There's one at -3, there's one at -1, there's one at 4, and there are 2 at 0, because x squared is really x times x. So there's 2 zeros there. And you call that multiplicity 2. And when you have multiplicity 2, it does not cross the x-axis. It touches it and goes back the other way. In the same way that if I was graphing x squared, it touches at the 0 and bounces off. It does not go through.
Mm-hmm.
Because there are 2 zeros. They both are at 0. But anyway, maybe we should do your next problem rather than getting in more complicated than they're giving. Do you have any others on this problem, or should I erase this?
I don't have any others on this problem.
Okay. What else you got?
Okay, so the next one is a of x is equal to x squared plus x plus 1. And b of x is equal to x minus 1. And then it says we can rewrite a of x over b of x as q of x plus r of x over b of x. And so then it says where q and r are polynomials and the degree of r is less than the degree of b. And it's asking what is
Hold on, I kind of got lost after the b of x.
Okay.
We've got an a of x function here. We got a b of x function. Is there a q of x and an r of x?
Yeah. So it says you can rewrite a of x over b of x as q of x plus r of x over b of x.
Hold on. So a of x over b of x can be rewritten as what?
Q of x plus r of x over b of x.
Okay. Yeah, what they're basically saying is if I divide a of x by b of x, I will get an answer and I will get a remainder. So let's do it.
Okay.
X minus 1 divided into x squared plus x plus 1. You have not had synthetic division yet, is that correct?
Like, is it where I would put x on top and then multiply it by x and -1?
That's regular long division, and that's the way I was going to do this. They have a method that they call synthetic division that speeds that up a little bit.
Okay, so I think we might have worked on that. Is it where, like, you take the number?
You take the 0, which in this case is +1, and you put it in the box, and you put just the coefficients down. Let's do it both ways.
Okay.
You need to know how to do it this way for sure. And then I'll show you how to do it with synthetic division if you like. Okay. But doing it with long division, yeah, you take the x, you divide it into x squared to get x. Then you multiply the x by both terms. So I get this. And then you subtract. You're always subtracting when you're doing long division. Well, x minus a negative x is 2x. Bring down the 1 and repeat. Now x goes into 2x plus 2 times. Multiply the plus 2 times both. Subtract. And you get +1. No, you get +3. So that's your remainder because we're now, we don't have any more x's. We We've run out of x's. We just have numbers. That has to be a remainder. So this r of x over b of x is plus 3. That's r of x. And b of x is the x minus 1. So there's your answer. And it's exactly in the form of q of x, which is x plus 2, plus r of x, which is 3, over b of x, which is x minus 1.
Okay.
Okay? Now, just to show you a little bit about synthetic division, over here, I put the 0 for that factor, which is a positive 1. And across the top, I put the coefficients of the polynomial that I'm dividing into. In this case, it's 1, 1, and 1. Draw a line. First step, bring down the 1. Next step, multiply the 1 that's in the box times that 1, write it there. Next step, you add. Next step, you multiply. 1 times 2 is 2. Next step, you add. There's your answer.
Okay.
Notice that what that is 1x plus 2, and that's your remainder, with a remainder of 3, and it's always divided by your divisor, your remainder is. The only difference between synthetic division and long division is they take out the variable. Notice I don't have any x's over here. I've got just coefficients. And because I have a positive 1 instead of a minus 1, I'm able to do everything with adding instead of subtracting, which is a lot easier for most people to add rather than subtract. Whereas when you do long division, you're always subtracting. In other words, I had to subtract right there. I had to subtract right there, and I got to subtract both terms. And notice that makes it x minus a minus x. So synthetic division really is a much faster way of doing these if you have to do a lot of them regularly. And you actually do, once you get into third degree polynomials, you do have to try to divide a lot. So synthetic division is really valuable as you get into precalculus.
Okay.
Okay? You understand everything that we did there?
Yeah.
Okay, it's almost 7:30. I don't know if you have a quick one we can do. We can do another one if you want.
I'm not sure how quick this would be, but this is just the next
Okay, what is it?
one that comes up.
Let's go ahead and do it.
So it's find the value of c so that x plus 2 is a factor of the polynomial px, and it says px is equal to x to the 4th plus cx squared plus 4x minus 1.
So we need to find the value of c such that x plus 2 would divide into that evenly. Well, I'm going to do it with synthetic division.
Okay.
Now across the top, 1 is the coefficient of the x to the 4th. Are we missing an x cubed?
We are.
So I got to put a marker in there, 0. Whether I'm doing synthetic division or long division, I have to account for every degree of the variable. The next number I would write would be the coefficient of the x squared, which is c. And the next one I would write would be the coefficient of the x, and finally the number. Okay? So, you remember how to do this?
So first I'm going to want to multiply.
Excuse me, there's one very important fact here. And that is that in order for that to be a factor of this polynomial, I have to come up with a remainder of 0. Otherwise, it's not a factor. That is the last number. That better come out to be 0. Well, that's useful because now I can figure out what C has to be in order to make that 0.
Yeah.
The first thing I do is drop the 1. Then what?
Multiply it by -2.
And write it right there. Now,
And then add.
I'm always adding.
Mm-hmm.
Multiply -2 times -2 to give 4. And when I add those, I get C plus 4. Now I multiply -2 times C plus 4. I'm not sure if this is the easiest way to do it, but it's the only way I can think of at the moment. And now I add those, which gives me -2C minus 4. Are you with me?
Yeah.
Multiply that by the -2, gives me 4C plus 8. And now 4C plus 8 has to add to -1 and produce a 0. So -1 equals 0. And wow. Didn't expect to get a fraction as an answer, but did I make a mistake in my math? Let's see, if I add those two, I get 7. I have to add the 0, which means 4C equals -7. C equals -7/4. That's the C I got. Seems like a strange answer. It's past 7:30, so we'll go ahead and end it there, and I'll study this a little bit and see if I did my arithmetic correctly. But we can always, actually what I'll do is put that into Wolfram alpha with -7/4 and see if that's a 0. Because that doesn't seem like it's a 0 to me.
Yeah.
But anyway,
into like the
sessions tomorrow and the next day, so we can revisit this a little bit if we need to.
Okay.
Okay?
Yep.
All right, Jonathan. You have a good rest of your evening. I'll talk to you tomorrow.
Okay.
It's nice to do some hard problems for a while.
Yep.
It's been a while. Okay. Bye-bye.